Okay, friends, please welcome Clemens from Microsoft. Clemens, take your time, right? The next thing, we've got time, so, just ease into it, it'll go well. We don't need to worry about the delay.
Yes, okay.
Okay, thank you.
Good. Hi, my name is Clemens. I work for Microsoft, and I'm a little louder than the previous guy. Yeah, okay, great, good. I work for Microsoft. I'm a product architect. I'm going to give you no walkthrough through the products that we have. I'm sorry. I'll tell you a little bit about it, but I'm going to give you a 45-minute architectural talk about eventing serverless and the extensible enterprise, and I'm going to start with that. I am the technical committee co-chair in AMQP in Oasis. I'm a spec owner of like 5 specs in the CNCF Cloud Events effort. I'm the co-architect for the OPC UA PubSub specification, so I'm doing a lot of standardization work for Microsoft in the open standards arena, and I'm also the product architect for a few services out of this box, which all have to do in some form with messaging inside of the Azure Cloud. Our team is the messaging team. We own Service Bus and Event Hubs and Event Grid and the Relay. We also invented in our team the IoT Hub and the notification hubs, which we then, and actually also the logic apps, which we then were then taken by other teams to own. I'm going to start with event-driven applications. I'm going to start with a little application scenario for you to get a feel what I mean when I say event-driven applications. We're going to start with a photo scenario. Let's say I'm a photographer and I'm out there in the field and I'm shooting photos for sports. Actually, let me back up and say one thing. My first IT gig ever that I got paid for was here in Athens in 1991 for the Mediterranean Games. And I was here to capture data, help capture data for participants and also for timing data for a German company called Vigedata, who was the general contractor for all the TV data providers and all the data collection for all these things for the Mediterranean Games. So sports is a thing that was my first paid gig in IT here in Athens. So let's say there's a photographer, and the photographer shoots pictures somewhere on site of a sports event. They're out shooting, and they're uploading their pictures, right? They end up in a blob container somewhere. You could also probably shoot with your phone. The way you do this is from your mobile device that's networked. You go and call a function, a lambda function, whatever, and you put that into the blob container. What we can do on our platform, which other platforms can now do, is they can raise events when you have inserted a new file into your blob container. So the event gets raised, and then we call another function, which then comes back to that original file, normalizes it, does auto-classification, auto-tagging, AI-based services, and then puts that into the inventory container. So there's an ingress container, and there's an inventory container where now that particular file is cataloged, and then we can also have an extension point here where we can raise the event that the photo has been ingested. Then, now that it has been put into the inventory, the next step is we're going to go and also raise an event out of this, which creates a bunch of thumbnails. That flow so far doesn't require that you write anything that listens. You simply write a function that will go and write something into the blob store, and then on the blob store you put an event handler which then triggers further action. You can completely automate that flow with serverless activities. It's simply just functions and hookups into an event router, in our case, in our platform, the event grid. So you create these sized images. That's what the function does. It stores those into the container, and then you raise an event into the index database to update what images are available. At the same time, from photo ingested, you go and raise that event. Hey, there's a new photo. into several apps in the newsroom. There's someone who manages the pictures, there's someone who edits the pictures, there's someone who is actually in the newsroom and writes the articles, and they go and publish the picture. And here in this case, it's not sports, but it's aircraft in trouble, right? So now there's so news goes out, something needs to be done on the picture because they forgot, masking something, they need to do some updates. So there's the person who does the Photoshop editing, or someone who does that on their phone, and they're going to do an update into the database. The photo is then being re-indexed, being pushed over on the other side. It's also going to be pushed into the inventory. It's also going to be resized, and as that has been resized, that's going to be published, and the published asset is going to be updated in the application. All of these things can be done totally event-driven. You can just realize that entire application as an event-driven flow that is just driven by these lambdas, just driven by Azure functions, just driven by OpenFaaS functions, which is pretty remarkable. You can do super, super powerful things. Let's look at another scenario, building management. You have a building, and there's a lot of things that are happening in buildings. So there's really two angles to this. There's the functional area of building management, and there's the other angle of dealing with all these devices that you have in a building. And buildings are fairly thoroughly instrumented these days. So let's look at some sensors that are in buildings and what we can do with them. Here's a building that has a bunch of sensors. The sensors are for gas and biohazard detection, for climate control, climate sensing, for fire and smoke detection, and for occupancy. Okay? These sensors are organized in a meaningful way in your environment, and that is, they're sitting in rooms. Right? Each room has one of each of these sensors. Those rooms exist in units. 4 rooms, 10 rooms make a unit that you can rent. Those units are spread across floors. Those floors are inside of a building. The building is on a site or a campus, and the site is managed by some organization. That sort of topology is very useful to think about when you're organizing the way how you want to collect and handle events from all these different sensors, because eventing really also means that you need to have an architecture for how you think about collecting those events. So ultimately, you're going to map these sensors into your eventing taxonomy, or sorry, topology, and have them emit events in the context of that. The devices are being installed, and they are being made aware where they are in that context. And that's something that matters. You can also do that in the backend system and associate the device ID effectively with that topology, if you like. When you organize things this way, you can start asking interesting questions. For instance, you can ask the questions, are there people in the room 41, building 41, floor 3J, room 4? Right? What room is unoccupied in which building? These are all interesting questions you start asking, and when you ask them, you can actually answer them by queries into your event stream and into your immediate event history. And some of them you can answer effectively in real time as you're observing that stream. So are there people in room 41, 3J4? You subscribe effectively, you observe everything that comes in for that room from that particular occupancy sensor, and you can effectively calculate by watching, what is the latest of what that sensor is sensing is whether there are people in that room. So that's a very simple one. What room is unoccupied in building 41? Well, you take all of the occupancy sensors and watch them, and then you decide based on the data you have for those rooms, you decide for the one that is obviously empty. It's also something that's yielded by the event stream. Is there a fire alarm at the site anywhere? Well, you obviously observe all the data from all the buildings that are on your site, and you see whether there's a fire alarm. How's the air quality? So you can ask all these different questions, and ultimately they all come down to eventing queries. So that's what makes eventing so interesting, because eventing is the capture of information, and we're going to get to that in a moment when I talk about the taxonomy and how we think about these things from an architectural perspective. Let me get to services and microservices and how that all plays in that game. Serverless, first of all, and this is something that the marketing people will hate, is really platform as a service. It's ultimately what is today the trend to serverless is a extreme, effectively new development on top of something that we had started in 2006, 2007, with some of the services that we built in Windows Azure back in the day. And that is, we believed at the time that it would be the right thing to do would be to just provide the upper two layers and take away all the work from everybody else. When you look at Windows Azure Cloud Services, as we shipped that initially as preview in 2008, it was kind of like that. You give us an app and we run that app for you. You don't worry about all the other things. What didn't work about that strategy is that people are bringing complete VMs. They want to go and move existing workflows into the cloud, and AWS was simply better at that. We have now progressed to the point where the VM stuff and arguably also the container stuff is well established, and now we're all going upstream, so we're coming back to those ideas. Generally, on premises, you own everything down to the hardware. In infrastructure as a service, and arguably also in containers, you own effectively everything, including the operating system. With containers, you own effectively the application server that is Linux user land, right? And with IaaS, you also own the kernel. That's the real difference. With platform as a service, you only own effectively the app that runs on top of the application server. There are multiple layers of this serverlessness. You can either go and get a managed cluster. That is a model that we have in our platform in the form of Service Fabric, where you stand up a cluster, or a cluster gets stand up for you. And you can go and deploy applications into that cluster, and now you get an environment that can host your applications for you, but it's not constrained to a single node. That's something you also find in actor platforms like Akka, or you find that in Orleans. Then there's Matters Middleware, which is everybody's web server. You go into any of the cloud platforms, and they have the web platforms effectively. That's what that is. And then you have managed functions, and that is Azure Functions, AWS Lambda, and all these different managed functions platforms. IBM Cloud Functions exists, Oracle Functions exists, all those different things that effectively give you control only at the function level and give you a deployment model at the functions level. And that's where everybody is currently looking at as the new serverless paradigm. Let's take a step back into principles, because I'm going to get back there. But functions is a fairly extreme step, because now, how big is your application? Is your application really just one function large? There was a question that was asked earlier that I heard here, is like, my application gets so complex. If I have 1,000 functions, how do I even think about them? Are they all individual applications? And I don't think that's true. When we started, and when I say we, I mean the industry, when we started this whole notion of service-oriented architectures in the late 1990s, we worked out a few principles, and there was consensus being worked out around some principles of what services are. And I believe that's all still true. A service is responsible for holding, processing, and distributing particular kinds of information within the scope of a system. So it owns a particular slice of stuff. You can independently evolve it, build it, deploy it. It communicates with firm conventions. It follows certain contracts. It protects itself against unwanted access, which means it is itself secure and provides access control over the resources that are behind it. And it also provides reasonable failure management capabilities. That's something that this all has been true since the late 90s as core principles of service orientation. And then came the vendors of the enterprise service bus and kind of destroyed a lot of that knowledge. And then the microservices trend came and brought these principles back to the forefront, which was great. But if we distill this down, if we look at kind of at the core of it, it's really about autonomy. It's really about the people who built these things, so a service is autonomous, owns all of the state, it owns its database, it owns the schema of its database, it owns the communication contract, it owns everything is owned by the team, effectively, that owns the service. There's no shared state. If you have a service here and a service here and they look at the same database, they are one service. Because they cannot be independently scaled, they cannot be independently evolved. So one service has effectively one underlying data store, and how that data store is chosen, whether that's a flat file, a relational database, a MySQL database, Elasticsearch, whatever, doesn't really matter. That autonomy, the autonomy that a service owns effectively its entire stack from top to bottom, its contract down to the data storage, and that it's an isolated model. That is the only way how it's possible for an organization like Microsoft and the Azure team to build 200 different services without central coordination. We do some alignment of planning on interdependencies, but my team doesn't tell another team when to ship what. And we don't have a day on which we all ship, and there's no great ship room. Every team ships their own services, completely independent of everybody else, because we're following these principles. Our service doesn't get into another service's hair on the back, because it's impossible. All those services are autonomous. It's a principle that works. So the modern notion of service, as an evolution of the thoughts that we had in the end of the 90s, is that it's not about artifact counts or sizes or technology choices or any of those things. It's really about teams. So the notion that have a bunch of functions is not at all in conflict with building a service. The service is just made up of more components, so you have more flexibility. So when you think about service, think about a fleet of things that are related. Think about a deliverable that your team owns, and that may actually be made up of a number of different functions, a number of different lambdas, and a combination of things. You may have stuff that lives in a container. You may have stuff that lives in a function. Think of your stuff that you own as a fleet, that it belongs to a certain context. So then, when we take functions as a service and project that into that model, what we get is a fleet of functions that are belonging together, but they're still adhering to the same principles. They are all implementing contracts. They're adhering to that contracts. They implement versioning. If you are creating a new version of your service, you have to support the prior version of the service, because you can't tell anybody that you just broke them. Right? You need to have policies for when you're going to break contract. All of that remains true. Everything that when you read about the principles of service orientation, all of that is true for serverless. Serverless is just a new way of doing this and gives you more flexibility. I hope that cleared that up. The great thing about these functions is that they're independently deployable and versionable. You no longer have that big app. You know, the web service app that has 15 different endpoints, or 15 different methods, or 15 different resources if you do it as a REST endpoint, but you break them apart. The great thing is you can have a lazy service that gets a call per day, and a busy service, a busy function that gets 1,000 calls per second, all in the same thing. Right? You don't need to scale to the busiest piece, but you can have things that run on a leisurely place. You also don't have to have them listen all on the same interface. They don't need to be all HTTP services. They can quite well be driven by a queue. They can hang on Kafka, right? They can, the inputs the bindings to all of their data sources can be quite different. And that's all okay. So think of service as a conceptual fleet of things that are hanging together in that way. A system is then the federation of services. And when you look at a broader system, and you stick with that notion of service orientation, then it's also possible that you have parts of that system that you can take out and replace for many different reasons. So the Americans, for instance, will now want to have subsystems, and they're actually showing us that right now, that are GDPR compliant. Right? We now have entire offers from American websites that have no ads because they can't make their stuff GDPR compliant. So now we as Europeans get wonderful clean websites from them, or no websites at all. But it's like, so 4 different regions, 4 different legalities, 4 different markets. You may want to have pluggable modules, right? As you do this in modular software, and you can do the same thing with services as well. So the entirety of your system is, the entirety of your services is a system, but you still should think about when you think about what a service is that you still have modularity so that you can go and take business concerns separately out of your application. So, having level set all this, let's talk about eventing a little bit, because eventing is the glue between all these things. So we now have an example, we now have a bit of serverless, like how does all the compute stuff work. Now let's go and talk a bit about eventing, how we hooking all these things together. REST is what everybody seems to be doing, at least that's everybody's favorite. Everybody's doing all the things over HTTP. That is okay. That is okay until things get very busy and until you have call chains that are a little deep. And when you make a call, that makes another HTTP call, that makes another HTTP call, and that makes another HTTP call, and then all that stuff is strung together. This guy fails, everybody backs out, there's an error, and how do I ever get to that? This part, it's all terrible. So they're great to obtain immediate answers. To do stuff that needs to have an answer right now, it's great. To solve the scenario that I just described with the photo stuff, not optimal, because there's a lot of places here where you don't want to lose the information as it flows through the system, and that's where other options are better. So let's be a little methodical about this. Here are all kinds of different messages you can go and send to others. So you're building a system, and you want something from another system, or you want to tell another system what, there's all kinds of different things you can have. There's a command, you're expecting someone else to do something, and then they report back to you. You have a report, you tell someone else that something has happened. You take a file and transfer it to someone else. You had a notification, hey, something happened. You had to have a handover, which means you have done part of a heavy-duty workflow. Now you transfer control to another module, which then continues that work. You have a job that you want eventually to be done. So there's all kinds of different kinds of messages you can go and assign to others. They're not all the same. We can sort those into these 2 groups, which are really different in the core. Commands, transfers, queries, handovers, job, assignment, update, and request have something in common. And so do reports and notifications and measurements and traces, because these carry expectations. You do this, you send that message because you're expecting someone to do something. These are reports out where you are telling someone about something that just happened, but you leave it mostly to them what they want to do with it. So the distinction I draw here is between intent and facts. You have an intent as you're sending a message, and you simply are reporting out a fact. Those are very, very, very different, and they actually warrant different infrastructure to go and deal with them. And that explains, and I'll go into detail, while my team owns 4 things, right? We own Service Bus, Event Hubs, Event Grid, and Relay. 4 distinct services, they all do messaging. So there must be a difference. And no, for instance, Kafka is not the answer to all messaging questions just because it's modern and scaled. No, it just fulfills a particular set of patterns that are being useful here, but by no means all patterns that are useful. So we'll get to that. Messaging is all for intents. You have expectations, you lead conversations, you have contracts between parties, you control transfer between parties, and you, in the extreme case, also transfer values, right? When you make a bank transfer, also with Bitcoin, if you do a bank transfer, then you're actually moving value with that bank transfer inside that record. And to the extreme case, in Bitcoin, you are literally moving the value, not moving a reference. No, the value is the thing that you actually go and transfer. For that, Bitcoin has a pretty shitty messaging infrastructure, I have to say. Eventing, you have history, you carry context, you have some ordering constraints, and you have some schema. This is terminology that's used with eventings versus messaging. So messaging is all about a relationship. Eventing is all about telling other parties about stuff that just happened. Messaging example. You have a device. Let's say the device is a car. The device is roaming around the world. The device talks to the car, the control unit in that car, talks to the cloud gateway. And in that cloud gateway, there's a little queue for that car. Why is there a little queue for that car? Because the car drives into tunnels, the car drives outside the range of your mobile network, the car goes into all kinds of places where radio coverage is kind of spotty. So if you want to send information to the car, you can't send it straight there because you will never find the right moment when that car is connected if it drives through a series of tunnels in, let's say, Switzerland or some other hilly area. So you have a backend process, and that communication happens through some kind of a queuing system that sits in the middle where you have very, very many little queues that are doing that managing that conversation. That is a message broker. And we realized that, for instance, in our world on Azure IoT Hub for that scale, and then for smaller scales, but things that need more robustness, where the device is, let's say, a POS system in a store, or whether it's an ATM, you would solve that through Service Bus. It's conversations. Another example is where you have a workflow. The backend process that you just submitted something into now needs to have a bunch of steps that need to do work, and you have a central workflow manager that goes and executes all those steps, and you can't lose a step as you're doing that work. That, of course, also is something for Service Bus and Azure and Logic Apps. If you're familiar with AWS step functions, that's our equivalent of that. Basically writes on top of Service Bus to go and realize that. So that's another form of super reliable messaging that you need, and that's a conversation that effectively that workflow manager has with all the steps, all the services that are being executed in that context. Events, so that was messaging. Events falls into two different buckets. One of them are discrete events, and the other one are series events. What you typically do with, if you're familiar with Kafka, what you do with that is typically, and what that is best for, is series events. Series events meaning event streams that are related. They're typically time ordered. They may have some further order criteria. They are partitioned by some context. And what they do is they typically report some kind of condition of a system. And what they are is they are what I call analyzable. You take a bunch of events in, you process them, you gain insight, and then you act on the insight you're gaining out of that series of events. Right? Simple example: if you have a diagnostics log that you use for debugging, and you look at a single record, that's often not useful. What you need to have the story of the bug as it kind of unfolded, and you're reading that entire log down for like a minute. That's the kind of correlation that we do in our heads for debugging, and that's the same kind of correlation that happens with stream analytics queries, in that they're always looking at numerous events over some period of time to do to gain insights, and that's also how most of those AI services work. Discrete events are different. Discrete events are independent. They're reporting some state change usually, and they're immediately actionable. My initial scenario that I talked about with the photos, all of those are discrete events. I created a new file in the blob store, right? That is a discrete event. I went and thumbnailed all those pictures. I'm done with that. Discrete event. All of these are discrete events. These discrete events are really a great extensibility enabler, as you just saw. The thumbnailing that I did in that scenario is something that I can add at any point in time, right? Nobody needs to know that, like, the thumbnailing is something that I can literally do as an add-on in the next phase of the project, because I'm just adding extensibility. Thank you for granting me another 10 minutes. So that's a great thing. We report these actionable things, and we can hook up into these infrastructures. Sales Lead created, I actually had a friend of mine, or actually a former manager of mine, but also a friend of mine, has started a new company. And they are doing some CRM kind of application, and we had a chat about this. And he said, and he showed me effectively how they're doing these event-driven sales lead application. I said, check that out. I'm actually doing that on my slides. What they're doing is you can capture a new sales lead, and then they have an extensibility model where you can basically hook up these handlers to that action of sales lead created, and that's how they're extending magically their applications, and are making it in a way that basic knowledge workers can do this, right? They hide all the details of how the extensibility stuff works, and they just allow people to go and hook up these chains of events, these reactive applications in their UI on the fly. And the reason why I have this little error here is that you report the change out, but if you report a change out, if you report something that happened, you don't have to include all the data that goes with it. It's sufficient, for instance, when you have this blob created. When you create a new blob and you report that out, you don't include the blob data. What you do is you give a URL and say, a new blob was created, go here. The great thing about this is you can give that event to very many people, but only those who actually have access rights to the blob can read it. So you're also keeping, by just reporting facts out, but keeping the data effectively, giving hints about what that data might be, but not giving them access to the entire data. You make extensibility easier while not compromising security at all. Data series processing is a little different. Data series processing, as you will do this in analytics, is you're pulling data towards you, because you have some stateful aggregator that builds a picture of the world. How did this device behave in the last 10 minutes, right? If you want to do this, you need to see all the events of the last 10 minutes, and you need to go and create an aggregate. That state bucket where that aggregate is, right, you want to go and pull towards that. And that is why you have an ingester. Ingester is different from a thing that helps out pushing. You pull the readings in from the device, you put them into the ingester. The analyzer then kind of walks up to the partition it's interested in, and then starts pulling the data towards itself. And this is something that we do, and that's the pattern that we use in Azure Event Hubs, which also now speaks the Kafka protocol. So if you want to have a managed Kafka, let me put a pitch in here. If you want to have a managed Kafka service for which you don't need to know any zookeeper, come to us, we have that. And it's much, much cheaper than any Kafka you have run yourself ever. Much cheaper. And you can obviously also do the same pattern in Kafka itself. Discrete events are different. You're pushing them into a distributor. The distributor then goes and has subscribers and pushes that out to the subscribers. Because they are independent, because there's no interrelation, you can effectively go here and freely load balance them across a population of receivers, because you don't need to keep them together. You only need to keep them together if you're aggregating into one place. So this makes this super suitable for distribution over HTTP, and that's why we're doing this here, pushing those things out over HTTP, and this is what we do in EventGrid. But also, there's a project in CNCF called the Event Router, which also does the same thing, and there's multiple, and SNS and AWS also does a similar pattern. So you see different infrastructures, SNS, EventGrid, Event Router, for these discrete event routes, which are push. Then you see Kafka, Event Hubs, IBM Message Bus, which is also based on Kafka, and some others for correlated event streams for pulling stuff out. And then you have these messaging infrastructures, may they be the Amazon MQ or our service bus or all the different message brokers, ActiveMQ, Artemis, Rabbit, etc., which are for the messaging workloads for conversational integration. For these discrete events, we've done a bit of work in standardization recently, and at the KubeCon Europe in Denmark a few weeks ago, we did a fairly spectacular 10-vendor demo, which I can't show you because now everybody has torn down their systems for the demo. But we were able to show that with a 0.1 spec, which we finalized 2 weeks before, we were able to go and spread events and distribute events in the way that I just showed you on the previous slides across 10 vendors and 10 different functions as a service infrastructures and cloud infrastructures to show that we're serious about interoperability. So what we're doing with CNCF and the cloud events effort, for which I'm the Microsoft delegate, so we're creating a common metadata set for events. We are having a very simple abstract type system, so you can basically now say, what does an event look like? What is the event type? What is the event time? What is the event ID? What is the event data? What's the content type of the event data? So like the basic things. And then we have a way to render that as JSON. We will have ways to render that as Avro and message pack, and we also have one that renders it at AMQP. And then you can go and take these encoded messages effectively and can put them on HTTP. We're having a webhook spec. We have an MQTT and 311 and 5.0 spec that is a draft that is in the repo already. And we have a PR for AMQP that's going to go into the repo hopefully tomorrow. Next week for this. So that's an exciting effort with a lot of vendors. And in our event grid in Azure, we're already supporting this, even though it's 0.1 and really in development, we are ready to support that in the product with full SLA for people to use. And that's something that we also announced at that conference. So generally, the way I think about event-driven is you have core functions of services that allow for direct interactions, and then you can effectively extend these services with hooks on the side, and you can do this as we're doing that work for cloud events, not only over HTTP, but also over all the other transports that are more for messaging services. And then the question is, how do I extend out to the edge? Because you have scenarios that need to reach a phone. How do you handle an HTTP request on a phone or on a machine that's behind a firewall? And that you can either route via queues, or you can use a relay. And just for you to get a little sense of that, I'm going to run a little thing. And of course, I need to go and end this thing here. Stop. Okay. Here's my little thing. So I just started a Node app. And now I'm going to go and get my Microsoft browser because, And the demo gods and this network in particular are helping. I will get a very boring message, but this network is not cooperating. Of course not. Okay, I will try that once more. this network is not very nice because that service that I'm just using certainly works. Demo fail. Well, lucky I brought some code on slide. So what you just couldn't see, but which works, and I proudly have the address here because it did work before, of course, and it always works except here, is the following thing. We have an extension in the relay that allows you to effectively listen for HTTP requests anywhere. So what we did is we have our relay service. The relay service allows you to project an HTTP listener or a WebSocket listener into the cloud. And this is a normal Node.js HTTP app. You say require HTTP, you set a port, you say create a server, and then the callback, as soon as an HTTP request comes in, this thing is getting called. What we did is we have a new package that you simply go and use instead, and then you create a relay server providing some information that lets you hook up to our relay, and with that, you can also now handle that HTTP request. The nice thing about this is this works anywhere. This works inside of a container. This works inside of your local machine, and the machine doesn't need to have a public network endpoint. We make the public network endpoint for you, and we give you HTTPS and all those things, and the only thing you need to do is have a relay endpoint. So that's actually combining, that's wrapping up that total picture of the services that we have. So total, autonomous software, organizational principles, think of services as grouping of things together that you own. Think of ownership as a primary thing. Platform as a service, various hosting options, functions is kind of the most advanced one, which takes away most of your pain, but also takes away a lot of your control. So figure out what you need. And then communication is the enabler, and event-driven applications is something they should pay attention to because they are enabling lots of very, very cool scenarios. I hope you found that entertaining. It was my pleasure. Thank you very much.
Hi.
Hi.
If you have a lot of functions and you group them into services, how do you handle the deployment of such things? In a way that they don't break and such stuff?
So, well, I don't think there's necessarily there's a difference in terms of how you proceed compared to writing your own set of EJBs or anything else that you deploy into an application framework or a website. I think you still keep them together in terms of an organization. Like I think a service might quite well be a repo, right? And then all of the functions that are belonging in there, that are belonging with that service, they go into that repo, and you've also versioned them together. What you do differently is you manage effectively the deployment is something that is independent. And the great thing about functions is that you really have the ability to have, you have these, because it's always that way. Like you have 20, 30 different things that you do, and there's 2 of them is where all the traffic is, right? And so now you can go and scale those 2 things appropriately while having the other ones kind of co-located and just deal with your resources better. Right? So I would think about it this way. So think of services as an organization, as a team organization, code organization boundary, and then think of the artifacts that you deploy as an engineering tool for managing your scalability better. Alex.
Hi, Clemens. With your example about the relays, and you saying that we can host things anywhere.
Yes.
Is this intended for sort of hybrid cloud deployment scenarios?
Yes. So the relay is, and I only had a little time, and the demo didn't work, which is sad, but owed to the network conditions. The relay is for hybrid connection, for hybrid scenarios, and we have a lot of those. Anytime you have a restaurant, point of sale, anything that is a bank branch, like any kind of place where you have some place that's out in the world, which is not in the data center and can't be in a data center because it needs to be close to people. In many of those, and then you have these scenarios where you have a vending machine that sits somewhere in an office, right? That you own as the operator of vending machines, but you don't own that office, and you don't own that office network. We have very many scenarios where a SaaS application that runs in the cloud needs to reach into these things. We also have doctors' offices, tax offices, law offices, all these different places where you need to have applications on site, and they must be on site. And for that sort of integration, the relay is ideal, because the relay gives you integration with that directly. In App Service, we also have a thing called Hybrid Connections Manager, which you can deploy on premises, and that gives you a WebSocket tunnel end-to-end realized over the relay, where you can go and talk to your local Oracle database or your local SQL database as if it was in the cloud. So where we're actually creating that WebSocket tunnel with outbound traffic only from the site, so no inbound connection necessary, but you get effectively a full-blown database connection out of that. So that's something that we do also. So that's for hybrid scenarios, lots of those having to do with branch office management, but also with on-site data centers, obviously. And it's a solution that terminates in layer 7. So you don't need to have a VPN. You don't incur the risk of a VPN. It's a clean application-to-application layer technology.
Okay. Well, thank you very, very much.
You're very well welcome.
Thank you.